Hello, my name is Fred Knight. I'm a Principal Storage Technologist at NetApp and an NVMe Express Board Member. Today, I'm here to discuss fabrics and multi-domain subsystem support within the new NVMe 2.0 library of specifications. We restructured the NVMe 2.0 specifications because of the expansion of the capabilities of NVMe technologies. NVMe technology has grown exponentially from its inception and taken on additional command sets associated with devices. For example, standard block access devices, zone block access devices, and key value type devices, along with some new types that we're working on now. We took all the various transports out from a single specification and created individual specifications for each of them. As a result, there's now the NVMe over RDMA specification, the NVMe over TCP specification, the NVMe over PCI specification, and the NVMe over Fiber Channel Standard. This allows implementers who need specific pieces of information to go to the individual specification to find the information that they need. This also resulted in the creation of what we call the base specification, which includes the common information that applies to all different types of NVMe devices and across all transports. It's important to know that the NVMe-oF technology term has not been retired, and it still represents the umbrella of fabric transport that the NVMe base specification supports. We still have NVMe-oF technology capabilities and products. However, the NVMe-oF specification has been absorbed into the NVMe 2.0 family of specifications. To be more specific, the fabric specification was merged into the base specification, and the fabric-specific transports were broken out into their own specifications, like the TCP transport specification and the RDMA transport specification that I mentioned earlier. The newly restructured NVMe base specification includes the fabric commands that are specific to managing fabric devices and performing things like device discovery and more. In order to more easily add new capabilities, we needed to restructure the NVMe-oF specification to allow us to make those revisions more rapidly. The new structure allows us to add new features to each of the command sets, to each of the transports, and to more easily do that, since we're now updating smaller documents rather than updating one large specification. The specification restructuring benefits developers by allowing them to reference just the parts of the specification that are relevant to the product that they're developing. I believe this will make it easier for the adoption of the NVMe-oF technology. The reading of the specification will be more cohesive, and each layer of the specification has its own document. So when implementing a fabric device for a particular transport, developers will no longer need to look at all the other transports in a single large document. They can examine the single document for the transport that they're working on. The latest features added to the NVMe 2.0 specification are mainly security-based and management-based. The new security-related features are called in-band authentication and transport-level security, that you may know as TLS. The management-related features enhance the automation of discovery for NVMe over TCP fabric devices. In-band authentication relates to the security of the connection and prevents spoofing from the endpoints. It allows the host to guarantee that the storage that it's talking to is who it actually claims to be, and vice versa. TLS, which is used by HTTP for TCP traffic, is now up to version 1.3. It secures the communication between the host and the NVMe over fabric storage devices. Discovery of NVMe over TCP fabric devices has until now been a completely manual process and considered by some to be quite complex. New capabilities have been added to enhance and to automate this process of discovering NVMe over fabric devices. The first simplifies the actions performed by the host during discovery. In addition, a capability was added to allow NVMe over TCP devices to be automatically discovered by hosts, much like network-based printers are discovered. We also created the capability for a centralized management point called a CDC for controlling access to NVMe over TCP devices. As for the benefits from these features, we create these features to be usable in all markets, ranging from client to cloud to enterprise. One interesting market example is banking. In banking, you need to know that you're talking to the right people on both ends of the wire. For example, this guarantees that the data isn't viewable by anyone else. These new features could also be used in the data center, such as making it easier for storage administrators to install and to configure NVMe over TCP storage devices within their data center. This added simplicity reduces the workload to install and manage an NVMe over TCP environment. The general public is able to get involved by downloading the specifications from the NVMe Express website. If you're an NVM Express contributing member, you can join the Fabric and Multi-Domain Subsystem group that I chair. Members of that task group get to review technical proposals and help develop the latest Fabric features.